either your if this transistor or this transistor, that should be worked only one, right? So whatever the gain coming across you, that should be due to that only one transistor, right? And other transistor should be off, right? So whatever the thing which should be coming with respect to class A, that should be eliminated by here. So in case of class A, there should be whatever the transistor used, that should be worked in case of your 360-degree half cycle, but here this should be worked 180, this should be worked 180, so total 360-degree. So burden on one transistor is not happen here, right? That is the advantages, but it have its own disadvantages, right? See, we know that with respect to diode, then we have applied the voltage with respect to diode, right? It is not worked up to the 0.7 or 0.3 volt. Why it is? Because that is called as cut-in voltage. All right. So up to that cut-in voltage, that should not work. The same thing will be happen with respect to the transistor. It is also constructed from silicon or germanium. So due to that 0.7 volt, it should not work up to the 0.7, means plus 0.7 volt to the minus 0.7 volt, right? So during that, म्हणजे हे जे ट्रान्झिस्टर आहेत ना, आपल्या ट्रान्झिस्टरच्या ऑन होण्यासाठी 0.7 volt थोडं व्होल्टेज लागत असतं, तर त्या पिरियड मध्ये ते ट्रान्झिस्टर ऑन असतात. म्हणजे काय होतंय, ट्रान्झिशन व्हायला, म्हणजे प्लस टू द मायनस किंवा मायनस टू द प्लस व्हायला ज्यावेळेस सुरू असतं ना, त्यावेळेस त्या पिरियड मध्ये हे ट्रान्झिस्टर वर्क होत नाही. त्यामुळे क्रॉस ओव्हर डिस्टॉर्शन, म्हणजे क्रॉस ओव्हर म्हणजे काय, पॉझिटिव्ह टू द निगेटिव्ह चेंज किंवा निगेटिव्ह टू द पॉझिटिव्ह चेंजला ट्रान्झिस्टर कुठलाही वर्क होत नाही. त्यामुळे तिथं डिस्टॉर्शन येतात, आउटपुट मध्ये तिथं डिस्टॉर्शन येतात. पहा, राईट, पहा ही तुमचा क्यू पॉइंट आहे. ह्या क्यू पॉइंट मध्ये काय सांगताय की तुमचा एक ट्रान्झिस्टर 360 डिग्री मध्ये वर्क होतो, लक्षात घ्या. ओके, we have discussing the class B amplifier, right? This is the amplifier which should be used for the solution of whatever the problem coming with respect to class amplifier. We know that class amplifier which should be worked in case of 360 degree, right? So due to that overburden on that amplifier, so to remove that burden, we have to be design the class B amplifier. Class B amplifier is the amplifier which should be worked only within a 180 degree half cycle. Due to that 180 degree half cycle, we have need of the two transistors for the particular operation. So that's why whatever the burden coming with respect to one transistor in case of class A, that is not coming with respect to class B type of the configuration, but it have what happened, it have to be used of the two complementary transistor. Complementary indicate that if one transistor used, that is PNP, then other must be NPN. Why it is? Because to work in a both positive as well as negative half cycle, we have requirement of the complementary transistor that should be used here. This should be active in the way of push-pull way. Push-pull means what? One transistor should be on, other should be off, other should be on, one transistor should be off. This is nothing but a push-pull type of the arrangement, right? So that each of the transistor, means during this period only one transistor should be on, right? So in case of class B, other thing is that in case of class B amplifier, there should not be need of the DC based bias. DC based bias means what? This is the DC voltage which should be applied across your transistor. So due to that DC voltage, there should be noise added with respect to your transistor, because in case of your transistor we require the AC signal, but in this case DC signal will be added with respect to it. So in this case zero DC signal is applied. So that's why DC power, whatever the DC power coming with respect to this transistor, that should be small. So DC power should be small, indicate that it should be amplified larger and larger AC signal, right? So AC signal amplification, no DC signal amplification, so no noise is added, so efficiency is more, right? So, but these are the some positive thing with respect to this configuration. See, but some of the disadvantages coming with respect to this configuration is that if its efficiency increased when we have to use the class B, or when we have to use the two transistors, but what happened, linearity indicate that whatever the input signal applied, that should not be coming with respect to output, means replication of input with respect to output, that should not be coming. This will be happened due to the crossover distortion. Crossover distortion means the transistor or the diode that should be constructed from your silicon or germanium. So silicon and germanium, its own operating voltage required, that is 0.7 or 0.3 volt. So during that small amount of period, your whatever the transistor during this crossover period means started from your high to low, means consider as a 180 to 360 degree or 0 to 180 degree. In that case, during small portion of time, there should not be any signal coming with respect to output. So this is nothing but a crossover distortion. This is coming with respect to class B amplifier. Okay. लक्षात घ्या, क्लास बी एम्प्लीफायर मध्ये काय असतंय, जसं आपण क्लास बी एम्प्लीफायर यूज करतो ना, तर क्लास बी एम्प्लीफायर यूज करायच्या आधी आपण पाहणार क्लास एम्प्लीफायरचे काय काय डिसएडव्हांटेजेस आहेत. क्लास एम्प्लीफायर मध्ये ज्यावेळेस आपण एम्प्लीफायर यूज करत होतो ना, त्यावेळेस तो जो ट्रान्झिस्टर यूज केला जात होता त्याच्यामध्ये तो पूर्ण 360 डिग्री मध्ये वर्क होत होता. म्हणजे त्या एका ट्रान्झिस्टर खूप बर्डन होतं, म्हणजे पूर्ण वेळ वर्क व्हायचं, त्यामुळे तो जास्तीत जास्त हिटेड होत होता. लक्षात घ्या, त्यामुळे तो डॅमेज भरपूर होत होता. तो जो डिसएडव्हांटेजेस कमी करण्यासाठी आपण काय केलं, क्लास बी हा मॉडेल डिझाईन केला. क्लास बी मध्ये काय केलं आपण, दोन ट्रान्झिस्टर यूज केलं, दोन वेगवेगळे एनपीएन एक असेल एक पीएनपी असेल. त्यामुळे एका 180 डिग्रीला एक एनपीएन किंवा पीएनपी वर्क होईल, दुसऱ्या 180 डिग्रीला अदर एनपीएन किंवा पीएनपी वर्क होईल. त्यामुळे एकाच ट्रान्झिस्टर बर्डन येणार नाही आणि त्या ट्रान्झिस्टर पुश पुल म्हणजे एकच ऑन राहील, अशा प्रकारे त्याचं डिझाईन केलेलं होतं. लक्षात घ्या, त्यामुळं ट्रान्झिस्टर बर्डन येत नव्हतं, त्यामुळे ते ट्रान्झिस्टर प्रॉपरली वर्क होत होते. आणि आणखीन याच्यामध्ये क्लास बी मध्ये आपण काय करत होतो, डीसी बेस बायस करंट जो असतो, म्हणजे तुमच्या डिव्हाइसला कॉन्स्टंट डीसी म्हणजे मिनिमम ऑपरेटिंग करंट जो असतो ना, तो मिनिमम ऑपरेटिंग करंट याच्यामध्ये इलिमिनेट केलेला असतो. लक्षात घ्या, मिनिमम बेस बायस करंट हा इलिमिनेट केल्यामुळं तुमच्या अम्प्लिफिकेशन ऑफ द सिग्नल फक्त एसी सिग्नलचं होणार आहे. लक्षात घ्या, म्हणजे इनपुट एसी सिग्नल अप्लाय केलेलं त्याच होणार आहे. त्यामुळे काय असणार आहे, डीसी नॉइज ऍडच होत नाही त्याच्यामुळे, त्यामुळे त्याची इफिशियन्सी मॅक्झिमम असणार आहे. लक्षात घ्या, आणि याच्यात जरी नॉइज कमी असली, हे सगळे ऍडव्हान्टेजेस असले तरी पण याच्या इफिशियन्सीच्या रिस्पेक्ट वाढली, बरोबर. पण लिनियरिटी म्हणजे इनपुटला जी सिग्नल अप्लाय केली तीच आउटपुटला वाढून मिळत आहे. तर काय होते, क्रॉसओव्हर डिस्टॉर्शन मध्ये, क्रॉसओव्हर डिस्टॉर्शनमुळे त्याचे क्रॉसओव्हर म्हणजे 180 टू 360 कडे जाणारा पोर्शन असेल तर 0 टू वाढणारा, म्हणजे दोन जिथं क्रॉसओव्हर होत असताना त्या पोर्शनला तुमची सिग्नल डिस्टॉर्टेड होते. कारण का, तर 0.7 किंवा 0.3 वोल्ट त्याच्या टर्न ऑन साठी ट्रान्झिस्टरचा लागत असतो. लक्षात घ्या, त्यामुळे हे होतं. See, when the input signal goes positive, I'm telling you, why the class B amplifier. There are two transistors. I'm telling you, there are two transistors used for the purpose of class B amplifier. When input signal, see input signal, there are two things, two half cycle, positive as well as negative. So during the positive half cycle, what happens? When transistor used in a positive bias, in that case, one transistor, positive bias transistor, either it should be considered as a PNP type of transistor that should be biased or that should be turned on, and other transistor NPN that should be biased with negative, right? So it should be turned off, right? So only one transistor means either your PNP or NPN that should be turned on in case of class B amplifier. So other transistors must be switched off. This will be happen in case of your class B amplifier. Now see, with respect to this type of transistor, this should be worked only one half cycle. We know that why it is one half cycle, because only one transistor is used for the case of 180 degree. So during that 180 degree, only one NPN or one PNP that should be used, other should be off. That's why overburden of this configuration is not happen here, because in case of class A, there should be all the 360 degree that should be worked, but here is not happen, right? This is the thing with respect to this type of the configuration. So what happened in this, whatever the input applied, same will be coming with respect to output, but due to only problem of the crossover distortion, signal should be distorted during the period of the crossover position only. Now see, push-pull design, what it indicates that. So push-pull indicates that there are two transistors used. If consider as a upper transistor as a PNP, then lower transistor should be NPN, right? So push pull indicate that when the positive half cycle, consider as when positive half cycle is coming, in that case already PNP transistor should be worked, right? So it should be act as a push. It means turn on of that, and due to that push means turn on of that transistor, other transistor NPN should be turn off, right? This should be happen in case of your class B type of configuration. So only whatever the input coming across, whatever the transistor should be worked here, that should be only one, right? Only one transistor should be worked, and whatever the problem coming with respect to class, that is heat dissipation, this is not coming across here because it should not be worked full 360, only 50 percent of the half cycle it should be worked, right? And the one disadvantages only is that I'm telling you, see, dead band of input base voltage from 0.7 minus 0.7 volt to the point plus 0.7. What indicate that? See, when we have to be bias the transistor or the diode, it should have requirement of the 0.7 volt or 0.3 volt for its working, right? So up to that voltage level, it should not be turned on, right? So during that period, whatever the voltage coming across your output, that is not coming. Why? Because during that period, no output with respect to your transistor. So this is nothing but a crossover distortion, right? Crossover distortion which should be coming with respect to it. So whatever the slide in that side, this is the portion where why the tutorial related to this transistor, why the actual thing happen, large amount of data over here that tell that why the 0.7 during this period no voltage is coming, that should be tell here, right? Click on that point in the link, there should be detail of it, okay? So in this case, then in a class B amplifier, the output transistor is not biased to an on state of the operation until voltage is exceeded. What it indicate that? So in case of class B amplifier, whatever the input coming, right? Whatever the input coming, it considered it should be coming in between 170 degree to the 180 degree, right? So during that period, what happened? The voltage is near about considered as a 0.7 volt, right? So during that 0.7 volt, no transistor should be on, right? So that's why that portion is not coming with respect to output, right? This will be happening in case of this class B type of the configuration. So this type of the configuration is also called as crossover distortion, right? Crossover means transition from 0 to the 1 or 1 to the 0. It is nothing but a crossover. This will be happen in this type, okay? So that's why class A type of the amplifier should be designed, which should be reduces the effect of the class B. See, this is the diagram of the class B type of the amplifier. See, when we have to be transition from 0 to the 1, see, more indicate that we have to be considered as a 1. So during that portion, there should not be any output signal coming, right? Output signal coming. So it is crossover distortion. So up to that, it should be again, means this signal increases during this period, it is no signal. When it should be increasing, again it should be reduces to 0, right? Means increasing from 0 to the upward or decreasing from the towards the 0. In that portion, there should not be any signal. So that during that portion, there should not be output. This is called as crossover distortion. This is coming with respect to class A, class B type of the configuration. This will be happen due to the 0.7 is the cut-in voltage required for your transistor. So to overcome that problem, we have to be design the class A B type of the amplifier. So see, class A B type of the amplifier is the combination. See, we know that लक्षात घ्या, समजा मी एक्झाम्पल घेतो, रोल नंबर 1 कन्सिडर करा. रोल नंबर 1 मध्ये काही ऍडव्हान्टेजेस असतील, म्हणजे की अभ्यास चांगला करत असेल किंवा बाकीचे म्हणजे प्रॅक्टिकल वगैरे व्यवस्थित करत असेल, समजा हे पॉझिटिव्ह ऍडव्हान्टेजेस आहेत. समजा रोल नंबर 10 कुणी का असेल, आता त्याच्यात काही त्याच्याकडे पण काही काय ऍडव्हान्टेज असेल, समजा की ते अभ्यास वगैरे नसेल पण खेळामध्ये वगैरे चांगला असेल आणि अप टू द लेवल ऑफ म्हणजे प्लेइंग वगैरे म्हणजे खेळ वगैरे जे असते त्याच्यामध्ये पुढे असतील, म्हणजे पॉझिटिव्ह पॉईंट त्याचे म्हणजे दोन्हीचे पॉझिटिव्ह पॉईंट घेतले ना तर ते अडव्हान्टेजेस होईल. सेम आहे म्हणजे अडव्हान्टेजेस थिंग जर दोन्हीचे क्लास ए चे अडव्हान्टेजेस आणि क्लास बी चे अडव्हान्टेजेस जर आपण एकत्रित केले, म्हणजे समजा क्लास ए चे हुशारपणा आणि बी चे तो खेळामध्ये हुशार असेल, हे दोन्ही अडव्हान्टेजेस घेतले तर चांगलं होईल. लक्षात घ्या. सेम वे क्लास ए बी मध्ये काय केलेलं आहे, द अडव्हान्टेजेस ऑफ क्लास ए and advantages of class B, they are coming with each other. It forms the class AB type of the amplifier, right? So this is used for the purpose of if we have to be only use the class A. Due to that uses, we have problem of the thermal power dissipation. So it causes damage of the transistor. If we have to be use the class B, it have advantages that it gives the largest output but linearity less. Linearity less means there should be coming of the crossover distortion, right? So if the both class A and class B advantages thing are taken, then that should be used for the application, and the sum of the disadvantages, that is crossover, that should be eliminated by using this class A B type of the configuration, right? So it is the combination of class A and class B type of the amplifier, right? So see, in this case what happened, we have to be design the amplifier, we have to be use the some of the positive thing of the class and some of the positive thing of the B that should be used. So that's why what happened, in case of class A amplifier, it should be worked up full 360 degree, right? We doesn't requirement of it. So what we have to do, see, class A used in that case it should be worked at 360, class B used 180 degree, right? So we have to be use the middle point of it, right? So we have to be use the amplifier which should be worked in the range of more than 180, less than 360, right? So what happened, whatever the crossover point coming, that should be eliminated. म्हणजे आपण काय करतोय, 180 पेक्षा जास्त घेतोय, 360 पेक्षा कमी घेतोय, तर मग काय ते जे क्रॉसओव्हर पॉईंट होतात ना ते रिड्यूस होतात. लक्षात घ्या. काय होतंय पहा, 180 पेक्षा जास्त केलं, ओके, तो क्रॉसओव्हर पॉईंट गेला. 360 पेक्षा कमी केलं मग त्या ट्रान्झिस्टरवर बर्डन येत नाही. लक्षात घ्या. ओके, दिस विल बी हॅपन. सी, so in this case what we have to do, we have to use this see, the two transistors have very small bias voltage. Bias voltage means operating voltage which should be provided to the transistor to work in a particular amplifier condition, right? Typically 5 to 10% of the quotient current to bias the transistor just above its cutoff point, right? So see, to work the transistor we have required the 5 to 10% of quotient current. Quotient current indicate that operating point current, right? Only 5 to 10% of the quotient current required for the purpose of your transistor operation, right? So see what we have to do. In this case, if we have to be used either your transistor or FET, right? So when we have to be used the device such as FET, in that case, if it is turn on, right, it should be turn on in only 1/2 cycle, right? So 1/2 cycle indicate that whatever the signal coming, that should not be working in a full half cycle, right? In case of it, but we have designing the transistor such a way that it should be worked more than half cycle, So more than half cycle indicate that the crossover point is coming with respect to half cycle. 180 degree च्या पॉइंटला तुमचा क्रॉसओव्हर पॉइंट येतो, तर तो इलिमिनेट होईल. आणि 360 पेक्षा कमी मुळे काय होईल की त्या ट्रान्झिस्टरवर बर्डन जास्त येणार नाही. लक्षात घ्या, राईट. दिस विल बी हॅपन, राईट. सो ड्यू टू यूज ऑफ द class AB type of the amplifier, the signaling of your amplifier is greater than 180 degree but less than 360. So due to the greater than 180 degree, there should be whatever the crossover signal coming means जे क्रॉसओव्हर डिस्टॉर्शन जात होते, म्हणजे त्यावेळेस कुठलीही सिग्नल नव्हती, ती सिग्नल तिथे येणार आहे. आणि दुसरी गोष्ट 360 पेक्षा कमी जर असल्यामुळे तर बर्डन येणार नाही. लक्षात घ्या. सो दॅट्स वाय we have to be prefer the class AB in case of your amplifier type of the configuration. See how we eliminate the 0.7 volt which should be coming across here. इथं डायग्राम मध्ये दाखवलंय की त्या 0.7 डिग्रीला जसं जे इफेक्ट होते ना तसे रिड्यूस झाले. See, this is the same as like as class B type of the configuration. same as like it. I'm not telling you it is same, right? So to eliminate the effect of the crossover distortion, we have to use the two identical diode with respect to this configuration, right? So due to the use of this diode, it should be worked on. It should be worked on during the period of the opposite. हे पहा एक जर एक ट्रान्झिस्टर तुमचा निगेटिव्हला ऑन होईल, दुसरा तुमचा पॉझिटिव्हला होईल, अपोजिट वे कनेक्ट केलेले पहा. म्हणजे प्लस 0.7 ला हा ऑन झाला तर -0.7 ला हा ऑन होईल. म्हणजे त्या पिरियड मध्ये तुमचा ट्रान्झिस्टरला सप्लाय करंटचा जो सप्लाय तो याच्या थ्रू होणार आहे. निगेटिव्ह ऑफ सायकल याच्या थ्रू होईल, पॉझिटिव्ह ऑफ सायकल याच्या थ्रू होईल. त्यामुळे काय होतंय, ड्युरिंग द पिरियड ऑफ द crossover there should be whatever the power required for your transistor that should be provided to this type of the diode, right? So that's why during that period, means during the period of 0.7 volt to the -0.7 volt, this during the period of -0.7 diode D1 is on, so it should provide the voltage to the transistor, and during the period of the +0.7 diode D2 is on, so it should provide the voltage to the transistor. So during this period, this is the crossover distortion period. So during that period, there should be provided of the signal. So positive of cycle is fully coming, and part of the negative of cycle should be coming. So that's why this will be happen due to the biasing of this two diode. या टू डायोड मुळे काय होतंय, या ट्रान्झिस्टर जरा जास्त 180 पेक्षा जास्त वेळ तो वर्क होतोय, त्यामुळे तुमचे क्रॉसओव्हर इलिमिनेट होत आहेत तिथं, लक्षात घ्या. त्यामुळे आलेली सिग्नल 360 पेक्षा 180 पेक्षा जास्त आणि 360 पेक्षा कमी डिग्री सेंटीग्रेड मध्ये तुमच्या आउटपुटला मिळते, त्यामुळे क्रॉसओव्हर रिड्यूस झालेले आहे. ओके, see the advantages of this small bias voltage provided by series diode or resistor is that the crossover distortion created by the class B amplifier characteristic is overcome. का overcome झाले लक्षात घ्या. जे required of +0.7 होते किंवा -0.7, that should be provided by this type of the configuration. As we have to be use this diode, it should provide the whatever the voltage we should be required for this type of the configuration. If consider as a positive voltage required for this transistor, in that case we see this transistor have required the positive voltage. So during that period, this diode D2 is worked, so it should provide the positive voltage, means +0.7 volt. When we have required the negative voltage, in that case the diode D1 is worked, so it should provide the negative voltage. So whatever the effect happen due to the crossover, means transition from your 0 to the positive or the positive to the negative, that should be overcome by this type of the configuration, right? So the class B amplifier is the good compromise between class A and class B in terms of efficiency, right? See, we know that in case of class A amplifier, in case of your class A amplifier, there should be a lot of problem, because it should be give the linearity indicate that whatever the signal, as I have told, that should be amplified linearly, means मी जे म्हणतो ना तेच तिकडे ऐकायला मिळेल, पण तुमचं हीट डिसिपेशन पॉवर जे आहे ना त्याच्यामध्ये जास्तीत जास्त लॉस होते, त्यामुळे आउटपुट जे मिळणार ते कमी असणार आहे, लक्षात घ्या. लिनियरली म्हणजे जे मी बोललो तेच अँप्लिफाय होईल, पण पॉवरची इफिशियन्सी कमी असणार आहे. बी जर यूज केला तर क्रॉसओव्हर डिस्टॉर्शन असणार आहे, पण हे दोन्ही जर एकत्रित यूज केले तर देर शुड नॉट बी प्रॉब्लेम ऑफ द distortion as well as the power dissipation. That's why we have to be prefer the class AB type of the configuration. It causes the efficiency is coming in with respect to 50 to 60%. Okay, give me the attendance. Number 1.
Present, sir.
2.
Present, sir.
3. 4.
Present, sir.
Ayu.
Present, sir.
6.
Yes, sir.
7. 8. 9. 10. 11.
Yes, sir.
12.
Present.
12.
Present, sir.
13.
Present, sir.
14.
Present, sir.
15. 16. 17. 18.
Yes, sir.
19. 20. 21.
Yes, sir.
22,
Present, sir.
23, 24, 25,
Yes, sir.
26,
Present, sir.
27, 28,
Yes, sir.
29,
Present, sir.
28 का 29?
29 present.
Okay.
28 पण.
30, 31,
Yes, sir.
32, 33, 34, 35, 36,
Present.
36, 37, 38, 39, 40, 41,
Yes, sir.
42, 43,
Yes, sir.
44. ऑप्शन नंबर सांगतो 3, 7, 8, 9, 10, 15, 16, 17, 19, 20, 23, 24, 27, 30, 32, 33, 34, 35, 38, 39, 40, 44. ओके,
Present.
कोण प्रेझेंट?
3.
ओके
20 present.
ओके. असाइनमेंट आणि मॅन्युअल त्याची लिंक आज किंवा उद्या टाकेल मी, लिहून काढायचे तुम्ही असाइनमेंट आणि मॅन्युअल. कोणाला काय प्रॉब्लेम आहे का? कोणते क्वेश्चन लिहायचे असाइनमेंट हे मी तुमच्या ग्रुपवर एकदा टाकलेलं आहे. ते आणि तेवढेच क्वेश्चन त्या तुम्हाला असाइनमेंटची लिंक दिलेली आहे तुमच्या टीचिंग डायरीला, त्यातले तेच क्वेश्चन फक्त लिहा. ओके, लिंक टाकतोय मी असाइनमेंट फायनल सबमिशनसाठीची. असाइनमेंटची पूर्ण तुमच्या 7 असाइनमेंट आहेत राईट. त्या 7 असाइनमेंटचे म्हणजे फाईल घ्यायची आणि ती PDF करून सिंगल फाईल, लक्षात घ्या सिंगल फाईल असेल तुमच्या असाइनमेंटची, ती सबमिट करायची वेगळी. त्यानंतर मॅन्युअल साठी सुद्धा तुमचे जे 9 स्टुडंट आहेत त्या सगळ्याची PDF फाईल करायची, ती सबमिट वेगळी करायची. लक्षात घ्या PDF फाईल करत असताना सिंगल एक स्टुडंटची करायची नाही, कारण त्यानं मिसिंग व्हायची शक्यता आहे राईट. तुम्ही फक्त असाइनमेंट करत असताना 1 to 7 एकत्र करायच्या आणि मॅन्युअल सुद्धा 1 to 9 एकत्र करून ते त्या लिंकवर टाकायचे. ओके, स्टॉप करूया आपण.